Hi friends, today we are going to be learn the elimination of left recursion and the elimination of left factoring. Generally, in the construction of first and follow of the given grammar, we are going to be use the of the left recursive and the left factoring grammar. That means that whatever the left recursion and left factoring grammar is eliminated, then that grammar is going to be used in the construction of first and then follow of the given grammar. Generally, the left recursive grammar can be represented as in the form of a tends to a alpha or beta format. So the production left hand side first symbol and the production right hand side both the symbols are seems to be same. So this is the simple technique to know that whether it is a left recursive or not. So such type of productions we are going to be replaced in the form of a tends to beta a dash and then a dash tends to alpha a dash or epsilon. Whatever the production is in the form of, this production can be replaced as so like that in this format. So now assume that if I given that an example of to construct the or to eliminate the left recursion for the given grammar, e tends to e plus t or t tends to t star f or f tends to open parenthesis e closed parenthesis or id. So now I ask you to construct the eliminate the left recursion. First of all, take the first production. What is the first production? The first production is e tends to e plus t or t and then t tends to t star f. So the first production is in the form of e tends to a plus e. It is in the form of e tends to a alpha or beta format. Now assume that so a is nothing but e and alpha is nothing but plus t and beta is nothing but t. Now how we doing replacing a tends to beta a dash? So that is nothing but e tends to beta is nothing but t e dash and then e dash tends to alpha a dash. Alpha is nothing but plus t and then e dash or epsilon. Similarly, if we consider the next production, the next production is similarly if we consider the next production t tends to t star f or f t tends to t star f. So now we are assuming that this production is in the form of a tends to a alpha or beta format. So here beta is nothing but f, alpha is nothing but star f. Now we are going to be represented as t tends to f t dash, that is nothing but beta a dash, beta is nothing but f t dash and then t dash tends to alpha a dash, alpha is nothing but star f t dash or epsilon. And similarly if we consider the last production, f tends to open parenthesis e closed parenthesis or id. So if you clearly observe that the production left side symbol and the right hand side symbol both are seems to be different, so we can easily saying that there is no left recursion. After that, so finally write down all the left recursive productions, eliminated grammar productions, that is nothing but production number 1, production number 2, so this is the production number 3, this is the production number 4 and this is the production number 5. So this is the eliminated left recursion grammar. If we consider another example, so let us example consider the C here. So now I ask you to construct the left recursion grammar, consider the given grammar and eliminate the left recursion. So what is the grammar that we have? S tends to open parenthesis t closed parenthesis or a or epsilon. So here t tends to t comma s or s. This is the grammar. So if we clearly observe that the first production is that does not have any left recursion. So if it is left recursion is available, then only we can eliminate the left recursion. So now so it is not a left recursive grammar. If we observe the second production, so t tends to t comma s or s. It is in the form of a tends to a alpha or beta format. Now we are going to replace this production a tends to beta a dash. Beta is nothing but s t dash and then t dash tends to alpha. What is an alpha here? Plus alpha is here it is comma s, alpha comma s, a dash is nothing but t dash or epsilon. So like that we are going to eliminate the left recursion. If you see the another example, third example, so let us consider the given grammar and eliminate the left recursion. The given grammar is s tends to ict s dash or a, s dash tends to es or epsilon, c tends to b. If you clearly observe that production left side and both side symbols both are to be seen as per the left recursion elimination rule. So that means that production is in the form of a tends to a alpha or beta format. So a tends to a alpha or beta format, both are to be seen, but if you clearly observe that there is no more left recursion. After the elimination of left recursion, the grammar will be same as it is. So in this way we are going to be eliminate the left recursion grammar. So if you see the another example, so see that another example of elimination of left recursion. See here, consider the grammar, eliminate the left recursion here. So when you are going to eliminate the left recursion, s tends to a or b, A tends to AC or SD or F. So now consider the first production. The first production is S tends to A or B. So here if you observe this, there is no more left recursion. That means that production left side symbol and right side symbol both are to be different. If it is same, then it is the left recursion. It is both are to be different. Don't bother about this production. So move on to the next production. The next production is A tends to AC or SD or F format. That means that A tends to A alpha and beta 1, beta 2 like that. If it is, then beta A dash, that is nothing beta 1 A dash, beta 2 A dash. Beta 1 is nothing but SD A dash, beta 2 is nothing but F A dash, and A dash tends to alpha A dash. What is an alpha? A alpha is nothing but C A dash or epsilon. So the final productions are whatever the production that we have, that is nothing but production number 1, this is the production number 2, so this is the production number 6. All these are the 3 productions. Okay, so generally if you take the productions, if you have n number of beta 1, beta 2, beta 3 like that format, consider the productions is of the form A tends to A alpha 1, A alpha 2, A alpha 3 and so on, A alpha n, beta 1, beta 2, beta 3 and so on, beta n. So then we can replace these productions are beta 1 A dash, beta 2 A dash, beta 3. All the betas are concatenated with A dash symbols, and A dash is going to be represented with alpha 1, alpha 2, alpha 3 and so on, alpha n. Alpha 1 A dash, alpha 2 A dash, alpha 3 A dash and so on, alpha n A dash followed by epsilon. Suppose if we take a simple example, if the production is A tends to A alpha or beta. Now generally we are going to be, after the left recursion elimination, we are going to be write down this grammar is A tends to beta A dash and then A dash tends to alpha A dash or epsilon. Suppose if you are going to be eliminate this epsilon also, then whatever the A dash possibility, the production is represented as A dash tends to epsilon. Whatever the possibility of A dash replaceable possibility in the right hand side, now we are going to be replace that epsilons. That means that I am going to be eliminate the left recursion without any epsilon symbols. Without, how we are going to be write down the without epsilon symbols, I am going to be explaining. So actually the production is A tends to first production. This is the first production, this is the second production. Beta A dash. If A dash is an epsilon, if you take this possibility, if A dash is epsilon, what is the production? That is nothing but beta. And if you take the second production, this is the first production. If we say the second production, A dash tends to alpha A dash. Suppose if A dash is an epsilon, what is the replaceable part or the resultant production in this production? That is nothing. If A dash is epsilon, then what is the remaining? Alpha only. So this is the elimination of left recursion for the given grammar without any epsilon symbols. If we consider the same thing in another manner, so that means that if we take the production is as a form, so A tends to A alpha 1, A alpha 2, A alpha 3 and so on, A alpha n followed by beta 1, beta 2, beta 3 and so on, beta n. How we are going to be replace that? Beta 1, beta 2, beta 3, beta 4, beta n. And then, so such type of productions are going to be replaced as A tends to, as for the productions, A tends to beta A dash, we have to be written. How many betas we have? N number of betas. That is nothing but beta 1 A dash, beta 2 A dash, beta 3 A dash and so on, beta n A dash. If A dash is, if you are going to be remove epsilon in such case also, so instead of epsilon, what is the next possibility? Beta 1, beta 2, beta 3 and so on, beta n. And A dash tends to alpha A dash, that is nothing alpha 1 A dash, alpha 2 A dash, alpha 3 A dash and so on, alpha n A dash followed by, if A dash is in epsilon, then what is the resultant production on the right hand side? So here we have alpha 1, here we have alpha 2, here we have alpha 3. That means that alpha 1, alpha 2, alpha 3 and so on, alpha n. So this is the possible, this entire is an extension to this one. So that means here we have considered that the production is only the alpha and beta, but here I am going to be considering that n number of alphas and betas. So this is the way of constructing the elimination of left recursion. So suppose if you are considering about the left factoring, how we to eliminate the left factoring? So generally the elimination of left factoring is going to be represented as, for example, see here. Here the production is of the form. The production is in the form, so A tends to alpha 1, alpha 2 and so on alpha n. We can replace that production is in the form of A tends to alpha x. So x is the unknown symbol that is nothing but one more non-terminal. X replaceable part is we are going to represent. What is a common term that is here? It is available 1, 2, 3. Common is nothing but alpha, and differentiating is 1, 2, 3 and so on n. So whatever the differentiating, that is going to be changing. Common terms I am going to be writing, differentiating terms I am going to represent with an x. X is going to be represented either 1, 2, 3 and so on n. So let us consider an example. S tends to SAB or SABA, SABB or SABC. Consider this production. After the elimination of this grammar, after the elimination of left factoring this grammar, so now I am going to be replacing this grammar is A tends to. So here the common is SAB is the common in the first production, second production SAB is the common, third production SAB common, fourth production SAB is common, differentiating is C only. So that is nothing, I can write down A tends to S A B and then followed by X. I am going to be representing the X is in the form of either A or either B or either C or either epsilon. Here the epsilon possibility why I am going to be representing. Suppose SAB, if X is replaced as epsilon, then that is nothing, first possibility of your right hand side production is going to be replaced. So this is the way of eliminating a left recursion and left factoring. So both are going to be used in the construction of first and follow of the given grammar. So thanks for watching. Thank you.